Today we're going to be solving linear systems by graphing. So first of all, we need to know what is a linear system. So let's take a look at a graph of a linear system. A linear system is two or more linear equations together in which we're looking for a solution that's for both equations. A really easy way to find a solution to a linear system is by graphing it. Graphically, it's very easy to see where that solution is. If we take a look here at this example of two linear equations that have been graphed, and you can see that the equations are x plus 2y equals 5 and 2x plus y equals 4. Those are the two equations that we graphed. The solution to this is right here, the point 1, 2. It's on both lines, therefore it's a solution to both equations. So the solution to this system is 1, 2. So we're going to be looking at a bunch of different ways to solve systems of linear equations in this unit. We're going to start out by looking at graphing, because graphically we can see visually where that solution is. Let's try a first example. It says solve the following system of equations by graphing. So we're given two equations, y equals x minus 3 and y equals negative x minus 1. Now, just like when we're normally graphing any sort of linear equation, we need to make sure that it's in y equals mx plus b form, so we can easily find our slope and our y-intercept. It makes it really easy to graph. Luckily for me, in this example, both are solved for y already, so I can just go ahead and start graphing. I'm going to start doing the first problem in purple, or red, whatever color comes up. So I'm going to start doing the first problem in red. Y equals x minus 3. Start with my y-intercept at negative 3, put a point there. And then my slope would be 1 over 1. So I'm going to go up 1 over 1 and put a point, up 1 over 1 and put a point, up 1 over 1 and put a point. Then I'm going to go ahead and draw a line. I'm going to use my line tool for this. Okay, and we'll draw a line right through those. See if I can get my line tool to work here. Okay, there we go. So I'm just going to extend this line so it keeps going through my graph. And I want to do that because I'm not really sure where the other equation is going to hit. So I want to make sure that I extend it through my graph as much as possible. So now I have the first line graphed. Let's go ahead and do the second line in another color. Let's go with purple, since that's what I thought I originally was going with. So I'm going to change my color to purple. And I'm going to graph this one in purple. This one is y equals negative x minus 1. So I'm going to start at negative 1 for my y-intercept, put my point there. And then I'm going to go down 1 over 1 because my slope here is negative 1. So down 1 over 1, down 1 over 1, down 1 over 1. If I grab out my line tool, and then I draw a line through this, now I can see graphically where those two lines meet and know that that's my solution. So here I can see that the solution to both equations is going to be 1, negative 2. Now I'll write that down. Solution is 1, negative 2. It's where 1, negative 2 is a point on both lines and therefore a solution to both linear equations. Okay, next one I want you to try. Okay, now I want you to try. Self-check. Go ahead and do this problem on your video or on your paper. The video will pause here. You can enter in your solution and your answer, and then you can check the answer as soon as the video starts up again. Make sure that you solve for y in order to graph your equations. Okay, go ahead and check your solution. Did you get it correct? Were you able to graph correctly? Most of the time when people get an incorrect answer, it's usually because they graphed incorrectly. Perhaps they did the wrong y-intercept or the wrong slope. Okay, let's take a look at classifying systems. There are two types of systems. We have a consistent system, a system that has at least one solution, and an inconsistent system, a system that has no solutions. So we're going to draw an example of each of a system of equations with each of the following. Exactly one solution, which is consistent. Infinitely many solutions, which is consistent. Or no solution, which is inconsistent. So let me get my line tool out. Exactly one solution, I'm going to have two lines that cross at one point. So that gives me one solution. So any type of lines that intersect are going to intersect at one point. In infinitely many solutions, we have one line, and the second line is the same line. So we can't even tell there's another line there because it is the same exact line. So we say it has infinitely many solutions. It's consistent. The two lines are the same. They intersect at all points. The final type is no solution, inconsistent. Inconsistent, we're going to have two lines that never intersect, and we call those lines parallel. So let's take a look at two lines that never intersect. Ta-dum! These two lines never intersect, therefore they're inconsistent. They have no solution. Okay, let's try graphing a couple more and see if we can apply what we've just learned. I want to graph this and figure out what the solution is, number one, and the classification. Is it consistent or inconsistent? So I'm going to start by graphing my two lines. I'm going to start with green on my first line, or blue. So for my first line in blue, I have a y-intercept of -3. And a slope of 1/2. So going up 1/2, up 1/2, and then I want to draw my line. Okay. My next equation is 2y equals x minus 6. Well, I want to quickly go ahead and solve that equation for y. And we'll do that in green. So 2y equals x minus 6. And if I divide everything by 2y, or just 2, excuse me, I'm going to get y equals 1/2 x minus 3. Well, I can tell already by looking at the equation that this is the same line. So my green line is going to be on top of my blue line. Same y-intercept, same slope. So my green line looks exactly the same. Therefore, my solution is I have infinitely many solutions. And therefore, my classification is consistent. Okay, now it's your turn. I want you to try to graph this equation, or this system of equations, and tell me what kind of solution I have and the classification. The video will pause here. When you finish, enter your answer and then press play. Did you get it right? This has no solution and is inconsistent because I have two parallel lines. I can tell almost immediately that I'm going to have two parallel lines because the equations are identical except for my c. So once I solve this for y, I find that my y-intercepts are different, but my slopes are the same. If you have any additional questions, please see me or any of the wonderful math teachers in our department, and we'll be glad to help you out.